This is video 2 of the Psych 642 non-parametric test assignment. I'm going to pick up right where I left off with the last video. I just tested the assumptions of normality and homogeneity of variance and found that this data does not meet the assumptions for homogeneity of variance, so it is justified to use the non-parametric test since the assumption was not met. So I'm going to go ahead and do that. So I'm going to run the Wilcoxon rank sum test on this data. I'm going to use the wilcox.test function to do that, to create the model. Anxiety is listed here as the outcome variable, therapy is the predictor variable. The data is specified as therapy data, and then paired is set to false because this is not a repeated measures analysis. And then to get the results, I'm just going to run the model. We can see here that there was not a significant difference between the groups. The p-value was 0.13. So to get the effect size when using the Wilcoxon rank sum test, you can calculate R from the z-score and the total number of participants. So I've written a code that will create a function that will do just that. And you can see it'll calculate the z-score using the qnorm function from the p-value of the model, and then use that z-score to calculate R. So I'm going to run that, and then I'm going to now run the R from Wilcox function that was just created with the model that we created and the total number of participants, which was 20, which gives an R of negative 0.34, which is a moderate effect size, even though the findings were not significant. So now that the first analysis is finished, I'm going to look at the therapy data 2 set and use the Kroskal-Wallis test to test for differences between the three different groups. So first I'm going to attach therapy data 2 so that I can use it in the analysis. Then I have to factor the therapy variable. So I'm going to do that using the factor function, setting the number of levels, which is 1, 2, and 3, and then giving the labels control REBT and CBT to the different groups. Then, just like before, I'm going to test the assumptions as well as give the descriptive statistics, and I'm going to do it the exact same way that I did before with the bi function and stat.dsc, the bi function and Shapiro test to test normality, and then using the Levine test function to test for homogeneity of variance. I'm just going to run all three of those. So descriptive statistics, you can see they're divided by group, and then a Shapiro test. You can see that once again, all three of these groups do meet the assumption of normality. And then for the Levine test, you can see that it is significant, which means that the assumption for the homogeneity of variance has not been met, which means that using the non-parametric tests in this situation is justified since we did not meet that assumption. Now that that is done, I'm going to create the model using the Kruskal.test function with anxiety as the outcome, therapy as the predictor, and the data being set to therapy data 2. Run that, and then we can see that based on the p-value, once again, there's not a significant difference between the groups. So it does not appear that REBT, CBT, or control had an impact on anxiety scores. If there had been a significant difference here, I would be interested in looking at the specific comparisons of the different groups, which can be done using post hoc tests, but because there was no significant difference found here, it's not really necessary to do that, but I'm going to do it anyway just to show how that's done. You use the Kruskal MC function, once again specifying anxiety as the outcome variable, therapy as the predictive variable, and therapy data 2 as the data set. I'm going to run that. You can see that this is consistent with the overall model here, that none of these specific comparisons came out significant. So that concludes the analysis. So now I want to take a look at the output and the summary that I've created, and show where the information in the summary came from. So, anxiety levels in individuals who participated in cognitive behavior therapy did not differ significantly from those who did not participate in therapy. So you can see that the medians are reported here for each of those groups, which came from the descriptive statistics that I found close to the very beginning. And then the information for the Wilcoxon rank sum test is reported here. The W value, which you can see here, was 29.5, and then the p-value, which is right here next to it, which was 0.13, and then also the effect size that we calculated, which was the negative 0.34 is found there. And then for the second analysis, anxiety scores were not significantly affected by participation in different types of therapy. The only thing that's reported there as far as numbers wise is the H score, the degrees of freedom, and the p-value, which we find in this output here. The degrees of freedom is 2, the H score is 3.29, which we see there, and the p-value is 0.19. If the test had been significant, then we would have also reported all of the information from the post hoc tests, including the observed differences. But in this instance, that was not necessary to report because the overall test was not significant. So that concludes the non-parametric test assignment, as well as a brief introduction and discussion to what these tests are and how they can be used.